TFlip Flops and Monostable circuits. Both of these are essential for some really complicated or even some rather simple machines. While they're two completely different topics of their own, they're both extremely useful, and different variations of each type will effectively always do the exact same thing. On top of that, they can do some really cool things when used together, and with several options of each, you can choose which one best fits your build. So, ready to learn about these two different circuit types? Then let's get started. What's up, agents? Zero here, and welcome to Redstone 101. This is the show that'll teach you more about Redstone so that you can build better contraptions. And the reason why I'm actually covering two different things at once is, one, there's only a small handful of each, and I didn't feel like making two shorter videos on them. And plus, they actually work really well together, which is another reason why I'm going to be doing these at the same time. So, like I said, TFlip Flops and Monostable circuits. Well, let's go ahead and get started with the TFlip Flops. Basically, in TFlip Flop, the T actually stands for toggle, and basically it allows you to use something such as either a pressure plate or a button to act as a lever. That's pretty much what a TFlip Flop is. Now, this first one we have right here is actually known as the Hopper Dropper TFlip Flop, and the way this works is that there's actually an item in this bottom dropper right here. If we go ahead and push this button, it's going to get dispensed into this dropper. Push the button again, it's going to get dispensed into this dropper, get pulled in from the hopper, and go back into this bottom dropper again. Now, this is actually one of the most compact TFlip Flops you can actually make. It's actually good for making really small circuits, so do keep that in mind. Now, obviously, you are going to need a comparator. That's kind of obvious. Now, this next one we're going to be taking a look at is actually the Hopper TFlip Flop. Now, the reason why this works is if you actually send a really short redstone pulse, it's actually going to change which item, which hopper, actually has the item. So inside of this chest, I have myself a simple building block. So if I go ahead and place this in front of my observer, it's going to create a short pulse and turn our lamp on. So if I go ahead and break this again, it's going to create another really short pulse and turn our lamp back off. Now, before we take a look at the next TFlip Flop circuit, there's actually a certain feature regarding repeaters that we need to know about, because this next TFlip Flop actually uses it. So, as you would guess, we can turn our lever on and off, and it turns our repeater on and off. However, if we go ahead and flick this lever, you see this bedrock bar? That means this repeater is now locked. So if I go ahead and turn this lever off, it's still giving a redstone output. So if I go ahead and flick this lever off, and flick this lever off, and then flip this lever back on, no matter how many times I flip this lever, it is not going to turn on. Now, the next one we're actually going to be looking at is known as the Repeater Redstone Torch TFlip Flop. And here's the way this works. It's using the exact same mechanic as right here. It's actually using a repeater to lock another repeater, preventing the redstone from going any further. So we go ahead and push this button right here. It's going to send a redstone signal around, and this lamp is now on, as you'd expect. And the same thing if we turn it off. Now, here's the way it works. This repeater is actually set to 4 ticks, and this one is actually set to 3 ticks. So when this repeater is off, redstone power from this torch will go through and cycle all the way around, and this repeater will turn back on just in enough time to lock this repeater and prevent any further redstone from going on. Now, there's actually 2 different ways that you can build this. You can build this with a wooden button, and you can build this with a stone button. I got those backwards. I'm an idiot. Okay. The reason why I built this twice is because stone buttons actually have a shorter pulse than the wooden button. So as you can tell, I've actually got 4 repeaters here this time. This one's set to 4, this one's set to 4, this one's set to 4, and this one is set to 3, and it does the exact same thing. You just have to keep in mind which button you're actually using when you're putting this together, because that's what's important. If you use the wrong amount of repeaters, or you don't have it set to the right amount of ticks, it's not going to work. So that's TFlip Flops for you guys. So next we're going to be taking a look at monostable circuits, and there's actually 3 different types. There's the rising edge monostable circuit, the falling edge monostable circuit, and the dual edge monostable circuit. So first we're going to take a look at the rising edge monostable circuit. The way rising edge works is that it gives a redstone pulse at the start of the redstone current. So if I go ahead and do this, the reason why this is working is because there's redstone power from this redstone dust going into this block, which is then powering the repeater, turning our lamp on. However, an instant later, about 1 game tick, this piston fires because this redstone is powering this block, powering the piston. That's going to cut off your redstone power to the repeater. Therefore, you're giving yourself a very short pulse. In fact, this is actually a 1-tick pulse, if I do remember correctly. Now, this one is known as the hopper-dropper monostable circuit, and it does the exact same thing, except the way this works is that an item goes from this dropper to this hopper, and then back into the dropper. So if I go ahead and press this button, like I said, it's going to do the exact same thing. However, this one actually gives a slightly longer pulse than that of our piston monostable circuit, because items in a hopper only take so long to get transferred. So that's what's creating our lengthened pulse. Now, the next one we're going to be taking a look at is actually the falling edge monostable circuit. And the way this works is that it actually ends up giving out your output at the end of a pulse. So if we go ahead and press this button, as soon as the redstone power from the button is gone, the redstone activates here and turns our lamp on. Now, the reason why I did not actually include a falling edge piston monostable circuit is because, for whatever reason, it does not work. I'm not quite sure why, but it doesn't. Now we're actually going to be taking a look at the dual edge monostable circuit, which there are actually 2 ways that you can build this. You can set it up so that either you have these stacked on top of each other or next to each other. You just gotta make sure one of them's inverted, or you can do something like this. So if I go ahead and flip this lever on, it's gonna create a short pulse from the lamp, and if I turn it back off, it's gonna do the exact same thing. Here's the way this one works. While this redstone block is moving, it does not give off a redstone output. So that does create a shortened time of which this redstone torch is actually on, because the redstone block is effectively inverting it. However, as soon as the redstone block is turned into a solid block, then that's when the redstone kicks back in and turns our lamp back off. Now, something I should probably mention is that while these blocks are moving, they're actually considered as entities. That's why the redstone block is not giving off a redstone current when it's moving. Now, you can actually use this for things like, for example, this. If I go ahead and do this, we actually have a shortened pulse, which allows our dispenser to give off water and then pick it back up. Now, this is actually very useful for map makers because, say, for example, you're building a laboratory and you want to actually set up a way so that you get like a quick cleanse. That's basically what you can use this for. So next up on our list is actually the observer block. I know I actually showcased the observer block already down there, but it's probably important to know that the observer block itself is actually a monostable circuit. It doesn't even need anything else. It's a monostable circuit all by itself. So let's go ahead and place this block down. If we go ahead and place this right here, as you can see, it turns our redstone lamp on for a short duration of time. So yeah, you can actually use it to do that. However, it does not give off quasi-connectivity because this block is what's getting the power, but it's not getting transferred. So it's important to understand that. So you have to give it a direct source of power, and you can't actually go through other blocks. Now, this last monostable circuit we're actually going to be taking a look at is known as the torch repeater monostable circuit. And this one is actually customizable. So if we go ahead and press this button right here, it's going to give ourselves a really short output. Here's what's going on. This torch is off for 1 tick, therefore this torch comes back on. However, 1 tick later, this repeater activates and turns the torch back off. Now, as I said, this one is actually customizable because you can actually set up to like 4 ticks if you really wanted to, and press the button, and the redstone lamp actually stays on a bit longer. Not too much longer though. However, you want to make sure that you do not set this to 1 tick, because if you set to 1 tick, nothing happens. That's because it takes 1 tick for this torch to turn off, and it takes 1 tick for this repeater to turn on. Therefore, you're effectively turning one off and the other one on at the exact same time. So you have to make sure that you have this set to a minimum of 2 ticks. Now, if you actually decide you want to extend the length of time that you do this, you can actually replace the button with a lever and get the exact same effect. However, with the lever, you can actually choose how long of a delay you want. And this is how you create pulse levers. So as you can tell, this lamp is staying on for quite a bit of time, and that's just flipping the lever down in one direction. Now, there will be a world download in the description. If you guys want to check this out for yourself, take a look at all the contraptions that I have in this world, but that's going to have to do it for this video. Hopefully you guys have enjoyed. If you did, make sure to hit that like button. Want more? Then make sure to hit that subscribe button for future content. Also, you can follow me on Twitter at AgentCPU0 to stay updated. This has been Zero Stews. Thank you guys for watching, and with that, I will see you guys later.